Hello everyone, my name is Anvita Bansal and we are back with another lecture based on hash map. So let's see what we are going to discuss today. Before that, let me check if you guys are able to see me. Let's have a look. Cool. So the problem for today is, let me show you, zero sum subarrays. Let's have a look at the problem statement. So let me just... The problem is that you are given an array of size n. Find total count of subarrays having their sum equal to 0. So you can relate this problem to what we solved in array, although this is, I would say, a simpler version. So we discussed about Kadani's algorithm, which is actually, and here we are not going to use that algorithm. It's a simpler version of that, I'd say. Okay. So what you need to return is that you are given an array and you need to return the count of such subarrays whose sum is equal to 0, right? And this problem could have been modified and made a better version by if they had asked you return the indices of such subarrays. So just the storage would have been different. So what, in short, what I want to say, this is the simplest variation of the problem of this type. Okay, so let me take one example. I have already written that in your custom input. I think it's not here. Let me take one example and show you how we can solve this problem. So let's take our test case only. After that, I'll take one test case that I actually modified for you to understand. Okay, so you're given an array like this. How many sub arrays can you find from this whose sum is equal to 0? So let's try to understand it. If I ask you, let me write it like this: 0 0 5 5 0 0. Okay, tell me how many sub arrays have their sum as 0. One way to find out this is you check all the sub arrays, you run a for loop, find out all the subarrays in n square of time complexity, and then you calculate their sum simultaneously and return the count of such subarrays. But this is the brute force approach, which we obviously do not want to go ahead with. So what can we do to optimize this solution? First of all, let's have a look at how we can see that subarray sum is 0. What is the sum of index element at this index? This is 0th index. Okay, the sum is 0. Okay, so I can say that one subarray I have found whose sum is 0, that is this array itself, right? And here I am just writing their indices, okay, at which index they are present, so that you do not get confused. Okay, the next one is this: the element itself is 0, and I can say that I can find another subarray whose sum is 0 with both these zeros in their array. So let me just write the index of this. This is the 0 from index 1. Now there is another subarray that I have found using these two zeros, and the sum is 0 again. So I have used indices 0 and 1 here. Okay, fine. Then I move ahead and I see this is sum 0, this is sum 0. I'm just kept on here. I am just going to calculate the cumulative sum. Okay, so let me write it as C sum. So C sum so far was this, then it was 0. Now 0 plus 5 again becomes 5. Okay. So till here I have got 3 subarrays whose sum is 0, right? When I got a sum of 5, I move ahead. Then I see what is the cumulative sum so far, that is the total sum so far. Now I will add 5 to it and it becomes 10. Okay, fine. So any more subarray with sum as 0? Not yet. These are the all arrays, subarrays whose sum is 0 so far. Now further moving ahead, 10 plus 0 is 10. Okay, so this is the cumulative sum, that is sum so far. Now wait, you have found a sum of 10 which is identical to what we just found before this index. That means if I have got an array, whose sum is just 0. It tells me what's getting similar sum. Why did I recall Kadani's algorithm? Because it tells you, I recall this thing because you can track that whenever we find the similar sum, whenever we are calculating the cumulative sum and we get a similar sum again. So what does it indicate? It indicates that, see, sum till here, let me show you this way. So this can be sum till this index. Okay, sum till here was what? 10. Fine. Now this 10 indicates that till here also your sum is 10 and till here also your sum is 10, which means all the elements that are present in this array and this array are giving me equal sum, that is sum of 10. So that indicates, what does it indicate? That okay, I found this sum previously also and I just added a number which did not change the sum, which means this must be 0 only. So from this you can say one thing: whenever you find a 0, that will always be included into your answer whenever you are returning the total count. Why? Just wait for some time, I will tell you why. Okay, moving ahead, 10 plus 0 is 10 again. So again you got a similar sum. You are proceeding, but you are finding that same sum you have got earlier also, which means that what you need to find? You need to find sub-array whose sum is 0. Okay, now let's calculate how many sub-arrays till here 0 0. Okay, you calculated and you put it here. Then we added 5 5. Okay, it's not giving me sum of 0. When I came at this position, what I found was it is 0. Okay, and this is at index 0 1 2 3 4, at index 4, right? When I came at this index, this itself will be added into the answer array. If let's say this is the list of all the sub arrays whose sum is 0, this is at index 5. And also, since you see that from here till here your sum does not change, that means the numbers are 0. So this in itself will also be one of the answers, right? This is at index 4 and index 5. Now tell me, how many such sub-arrays you found whose sum is equal to 0? So you in all found 6 such sub-arrays, and this is what you need to return. So this is just one test case that I am iterating through. Wait, before we move ahead, this is just one example. Let's check with another example that I have written for you. By that time, let me just see if you guys can see it. Okay, fine. Then just a second, let me take one more example that I took. One second, I just created it so that you guys can understand it better. Have a look here in this test case. We are going to understand it using this test case. So what I'm going to write is, it is 0. With this you will understand better. This is 0. 0 4 6 minus 12 2 minus 7 4, then this is 3, then it is 10, and then it is 0. Okay, so let me tell you, the answer for this one should be 9. Now we will verify that how we can find 9 such sub arrays whose sum is going to be 0. Let's have a look. Here let's calculate the cumulative sum, that is sum so far. So sum here at this index is 0. At index, this is, let me also write the indices here. This is index 0, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9. The question is very simple. I'm just trying to explain here or make you reach till that point where you can yourself figure out that what you need to do in order to solve this problem in a better optimized time complexity, that is not obviously in O(n) square, which we discussed in the brute force approach. So let's calculate cumulative sum here. The sum is 0. 0 plus 4 is 4. 4 plus 6 is 10. 10 minus 12 is minus 2. Minus 2 plus 2 is 0. Now wait. When your cumulative sum comes out to be 0, what does this mean? Your cumulative sum itself is 0. That means whatever elements were present, you started from somewhere and then you are calculating the sum, let's say it goes up, it goes down, and it comes back to 0, which means that whatever you must have calculated, be it like this or be it in whatever way, you got a cumulative sum 0. That means there must be some positive elements and there must be some negative elements which are cancelling out each other's sum and coming out to be 0. So one thing is, whenever you get a 0, if your cumulative sum is equal to 0, that means for sure one answer you are going to get from there. Is that clear? For example, when your cumulative sum here was 0, this element itself can be added. This is your answer array, answer list that I am going to create. So one answer already you got from this element. Then you kept on moving ahead and started calculating the cumulative sum, that is sum so far. So this was 4, then I came to 6, it became 10, then I moved to minus 12, it became what? Minus 2, right? And then I came to 2, minus 2 plus 2 became 0. That means what happened here, 4, 6, minus 12 dipped down a lot, and then plus 2, such that your total sum cancelled out each other and we got to cumulative sum as 0. This means that this lot of elements, these elements from here till which index, till this index, are giving me a sum of 0. Is that right? 4 plus 6, 10, minus 12, minus 2, plus 2, 0. So these elements itself can include themselves in one of the subarrays whose sum is 0. But do you also see one thing? Whenever there is an element 0, adding it can also give me one more answer, one more subarray. See, this itself was an answer, but I already have an element which is 0. So whenever you include 0, your answer is not going to get affected, but your number of subarrays whose sum is 0 will get affected. It will increase by 1. So 0 for itself as an element will be one subarray, and 0 added to another subarray whose sum is 0 will also be added to another subarray, right? So let me write the answers here. So one subarray which you found was 4, 6, minus 12 and 2. Then another one was 0, 4, 6, minus 12 and 2. This is one subarray. Now let's go ahead, move ahead and see. Then here it is 0. 0 minus 7 is minus 7. Minus 7 plus 4 is minus 3. Minus 3 plus 3 is 0. As and when your cumulative sum comes out to be 0, you need to do something. That is, you need to evaluate your answers, right? Okay. So when your cumulative sum is 0, which means that you have got some elements within some index that is giving you a total sum of 0, and for here those elements are minus 4, 7, 4 and 3, right? So these elements are zeros, another subarray whose sum is 0. Can you find more such elements? Can you find more such subarrays? From we stopped here, then we move ahead till here we got the answer, then further is this answer. Okay, minus 7, 4 and 3. Now tell me one thing, this is also 0, this is also 0. That means if I include whole of them, this subarray itself is giving me a total sum of 0. Now whatever previous answers I had, can I add these number of elements, this subarray, to all those answers and form a subarray? Let's check what my answer is going to become now. Now what I am telling you, that this is also 0 sum, this is also 0 sum, this is also 0 sum, and this is also 0 sum. Can I just concatenate these elements with these elements? Because the answer, that is the sum of 0, will remain unaffected. I am still going to get a sum of 0, but my number of subarrays are going to increase. So now moving ahead, the further answers will be something like this. Have a look. More answers are generated, and those answers are, you add to this 0, you add minus 7, 4, 3, 0. Sorry, for a subarray you need to have continuous elements. So minus 7, 4, 3 can be only added to the subarray if you have them continuous. So we know that I have this subarray, continuous subarray, in which if I add this one, it is also going to give me a sum of 0. So 0, 4, 6, minus 12, 2, let me write it here, it will be 0, 4, 6, minus 12, 2, minus 7, 4 and 3, right? From here only the next element that next sub array can be this 0, 4, 6 included all the elements from here till here. You can simply add to this also. So 4, 6, minus 12, 2, minus 7, 4, 3, right? This can be one answer. Can you have any more answers? So this included all elements from 0 till 2. Then what you just what you did, you excluded 0 and added your answer to this sub array. So this is what you got here, and this is the sub array itself. So how many answers you have got so far? 0, 1, 2, 3, 4, 5, 6. Let's move ahead and check the cumulative sum further. So here your sum is 0 plus 10 is 10. So wait, do you see one thing? You have got 10 here and you have got 10 previously also. So whenever you come across a cumulative sum which you have found earlier also, this simply means that sum till here is exactly equal to sum till here, which means the elements between them must be giving me, if I subtract, see, this is the total sum here, and this is also a total sum here. That means these elements are adding to give me a sum of 0. That is why my cumulative sum again came out to be 0. You're getting this point? So if you see 6 minus 12 minus 6 plus 2 minus 4 minus 7, that is minus 11 plus 7 is what I think. This is, just a second, let me check what all are giving me a sum of 0 from here till here. This is 10, 7, this will cancel out, minus 12, 2, minus 10, 10. So from here, so since till here your sum was 10, okay, let's assume that this is your sum, the elements are giving you a sum of 10. Then from this element some came, okay, this is the cumulative sum. Whatever sum you came, you are again coming back to, after certain point in time, you are again coming back to a sum of this. So whatever must be happening, what happened was there anyway, this is your cumulative sum, this is your cumulative sum. So this entire sum and sum till here, okay, both are same. That means the elements between them are giving me a sum of 0. So this is what is happening. If you calculate the sum from here till this index, right, where you are getting a sum which is repeating itself, cumulative sum which is repeating itself, you will see that the total sum is 0. What is the sum here? Start calculating from here. This is minus 12 plus 2 minus 10 here, okay. If you check, this in itself is 0, these will cancel out. Minus 10 plus 10 is going to be 0. So this is one answer that you are going to get. Let me write this answer. This is minus 12, 2 minus 7, okay, 4, 3 and 10. This is one. Why? Because whenever you found a cumulative sum that you have found previously also, that means the elements between them, exclusive of this first one, are giving me a sum of 0. So one answer I'm going to get from there. Move ahead. Now you are at this. So again you got a sum of 10, which means earlier also it was 10. This gave me a sum of 0. Now this element itself is 0, that is why I'm getting a 10. So I can handle the elements which are 0 separately to give me answer. So what your answer is going to be, you will get 2 from here, 2 answers, that is this cumulative sum means this entire sub array, and add 10, after 10 add 0, right? This is going to be one sub array and other sub array is going to be 0 itself. So these are the lists of sub arrays whose sum is 0. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So before I move ahead, let me tell you what did we observe here. We observed if your element itself, that is if your ARR, not ARRI, first of all, if your C sum itself is 0, right? If your cumulative sum itself is 0, add it to your answer. Whatever answer it is, add to it. Then you have to check, does your, we want to also keep a track if same cumulative sum has been found previously. So I am going to keep a hash map for this purpose. What is hash map going to do? You will see. So when I got a sum of 0, right, first of all I added to my answer, and then I added 0 and added 1 to it. That this is once that I have found 0. Then I move ahead, cumulative sum 4, it was not found previously. I added to my hash map and put 1 against it because this is the first time I found 4. Then 10, again 1, minus 2, again 1 because this is the first time I'm seeing it. Now when I am at 0, first thing is that one answer you are always going to get, because whenever your cumulative sum is 0, you are going to get one answer from there already, and then you will check why one answer already. Because see, if cumulative sum is 0, that means some elements have added, and then there must be some negative elements whose sum altogether has given you 0. So obviously a sub array is existing whose total sum is 0. So one answer for that you are adding, and then you are checking that can I also concatenate this answer with some other subarray whose sum is already 0. So I will check if my map dot contains this C sum. If it already contains, I am going to add answer into my answer. What I'm going to get, whatever was present as value in map dot get C sum, whatever was present in that, just I will add to my answer. And also map dot put. Now since you have found this element once again, so you are going to add one C sum and whatever was there, answer plus 1. This is what you are going to add to your map. If your C sum is 0, you already added, and in case you have found it from your map already, for let's say till now I have found 0 once, so the situation is already in your answer you have 1, fine. Then you found a 0 again. What happens is you add 1 to your answer already from this condition, and then you ask your map if it contains, what do you do? Yes, it does contain. You add that 1 to your answer and it becomes 3, and then you increment the count of this 0 to by adding 1 to its already present answer. In other case, if map does not contain, you simply put it in the map dot put that value C sum and 1 against it, right? And finally you return the answer. So what did we do here is, when I came at this 0, I asked my 0. What happens is, till here I am getting an answer of 3. How is it giving me an answer of 3? Let's check that. You will understand it. One answer, whenever I am getting a C sum of 0, 1 already I am adding to my answer, right? That is, there must be some subarray whose sum is 0. That is why only I have got a cumulative sum of 0. And then I am asking in my hash map, do you have this cumulative sum already existing? Yes. So it says just add it to my answer. Okay. So it adds to your answer and increments its count. So that is how you do it. Okay. This 0 itself was a cumulative. This C sum, when I was at this index, it is a C sum of 0. You already made your answer as 1 here, right? And this was updated with 1. And then finally when you came back to here again, in your answer you are going to add map dot get C sum. That is, you made it was 1 already, you made it 2, and then in your map you put it as 2. That's what you are doing. Okay. So I hope this much is clear to you all. Let's just go and code it, and then we will come back to the problem and discuss it and use a dry run on some other test case. Let's have a look. Any doubts so far, you can ask me. So in this question, now what we are doing, we are reducing our time complexity to big O of n, because we are doing it in one pass, and just that we are using some extra space of total maximum of on of space complexity. That is when we are using our hash map. So let's declare a hash map, initialize it. This should be of type long, and let it be long only. Okay. Map new. Okay. Let your answer be long type. It is 0. And long of C sum, cumulative sum also is 0. Now for int equal to 0, I is less than n, I plus plus. If your first you calculate C sum plus equal to ARR of I. Fine. If your C sum is equal to 0, right, you are already adding 1 to your answer. Whenever your C sum is 0, you are adding 1 to your answer, because that means you have found certain elements whose sum is 0 or the 0 element itself. So for that you are adding one answer. And you will also check if map did contain that dot contains key C sum. If the similar sum was found earlier, then what you are going to do? Then you are doing answer plus equal to 1. Why? Because if it already was present, then answer plus equal to map dot get whatever was present with C sum in your map. You will add those many to your answers, and then C sum dot put this map dot put C sum comma map dot get whatever was there C sum plus 1, because you have added 1 to your answer, for because this value itself has been repeated again, so you are adding 1 for that. Okay, in other case you are finding it for the first time, map dot put C sum comma 1, and then finally you come out of the loop and return your answer. Let's check here. That's all about this problem. Actually, it's a simple one only. The only thing is we just used a hash map to check if we have found that similar sum previously. If you have found, then you are going to add how many times you have found, so you will add that to your answer. And we are separately handling the case whenever your cumulative sum is 0. For example, here your cumulative sum is going to be 0, so you will add 1 for it, although the element itself is 0, but cumulative sum, whenever it is 0, you are always going to give your answer, add 1 to your answer, because there is definitely going to be one sub array which is existing to give you a sum of 0, total sum 0. That is why this case I am handling separately. And then you go ahead and check if, let's say, your C sum is 0 also, or even some other element, let's say 5, right, and it existed previously also, for let's say some other element was there and the total sum was 5, it was existing previously also. That means there must be some between elements whose sum is 0. That is why you are finding a cumulative sum similar to what you found previously. So for that reason we are doing this step, and otherwise you are finding it for the first time, just fill your hash map with that value and since you have found it once, so you're putting 1 here, and then you return your answer. So this is maximum taking big O of n time complexity, and for hash map maximum of n space. Okay, so that is all about this problem. If you have any doubts, you can ask me. Let me check what is the, let's say array is array id 1 2 3 4 5, then its answer will be 1. But why? Let me tell you. See, for this array 1 2 3 4 5, how your answer is going to be 1? Let's see. Let me just put it in the custom case, or if you want you can write the custom case in the chat. I will show you what answer should be. First of all, its answer should not be 1. I'll tell you why. It should be 0. If in custom case, let's say, let me give this, let me give a custom case. Okay, so let it be 6, and what you are telling me, let's give input as 1 2 3 4 5 6, right? If I am understanding from your comments right, then I think you are trying to say that this is the array we are giving, and its answer should not be 1 in this case. Do you find any sub array whose sum is 0? If you start adding from this element 1, you are only going to get some bigger value of sum, cumulative sum, and at any point in time you are not going to get a cumulative sum 0. So its answer should be 0 only. So let's check. Right? Okay, let's check. See, you're out. The code is also giving me, returning me 0, and expected answer is also 0, because you do not have any value which is giving you some sub array whose sum is going to be 0. The entire array itself is also not giving you sum 0, and if you find any between elements in this array which can be a sub array, they will also not give you a sum of 0. This is the reason. You want some set of elements, contiguous elements, whose sum can be 0. That is what you want. Okay. That is how we have to do. We have to, okay, let me take one more example and tell you. See, let's consider your test case is 1, 2, 3, 4. Okay. So tell me, how many subarrays can you find? First of all, let's try from brute force approach only. Let's say this is your test case. So in this test case, what can be the number of subarrays? 1, 1, 2, 1, 2, 3, right? 2, 3. These can be the number of subarrays, right? Am I missing anything? 1, 2, 3, 2, 3. Yeah, I am missing one length of subarrays. These are also subarrays. So one length of subarrays I have taken, two length of subarrays, 1, 2, 2, 3. So these are the total number of subarrays that you can find from this array. What you want to return is return the count of such subarrays whose sum is 0. Whose sum is 0. So now tell me, how many subarrays are you able to find from these whose sum is 0? What is the sum of this subarray? It is 1. Sum of this subarray, 1 plus 2, 3. Sum of this subarray, 6. Sum of this subarray, 5. Sum of this subarray, 2. Sum of this subarray, 3. Are you finding any subarray whose sum is 0? No. So how will you find it? Let's say I modify my array. I modify my array and make it look like this. 0, 2, minus 2. Let's say this is your. How many subarrays can you find from here? So one subarray can be 0, one subarray can be 2, one subarray can be minus 2, other subarray can be 0, 2, other subarray can be 2, minus 2, and last subarray can be 0, 2, minus 2. Let's check what are their sums. This is 0, this is 2, this is minus 2, the sum of this subarray is 2, the sum of this subarray is 0, the sum of this subarray is also 0. So answer in this case should be, what should be returned is, in this case the answer that should be returned is 3, because you are finding 3 subarrays whose sum is 0. Now let's check, is our approach able to find 3? So what our approach is doing, the code that I have written right now in the editor, what it is doing, that it is creating a hash map. Okay, it is iterating over this array from 0th index. It is calculating the cumulative sum. So cumulative sum when you are at 0th index is going to be 0, right? So what it says is, your code says you find a cumulative sum. If cumulative sum is 0, add it to your answer. Okay, since your cumulative sum is 0, I am maintaining my answer here. So here I am writing the answer. So right now it is 1 because you have found a cumulative sum as 0. Then what does your code says? If map contains that cumulative sum, then do something. So does our map contain this cumulative sum? No, it does not. So we go to the else case and add 0 here, and corresponding to 0 we add 1, right? This is what we are doing in the else case. Fine. Map.put. Now go into the loop again, calculate cumulative sum. What is, let me just take the snippet of code only so that you can understand. Where is it? Where is it? Okay, so this was your code. Fine. What are we doing? Have a look. I told you that your answer ideally should be 3. Why it should be 3? We are going to check now. So you are calculating cumulative sum. Now you are at index. What index you are at? Now you are at index 1. Your cumulative sum is going to be what? 0 plus 2 is 2. So your condition is if C sum is 0. So this does not hold true. Go to next case. If map contains C sum is 2, map does not contain. This will also be not true. So we go to the else case and we add this 2, and corresponding to 2 we add 1 because we have found it for the first time. Now you are at second index. What is 2 plus minus 2? That is 0. Now your cumulative sum is 0 again. So you go and check. If your cumulative sum is 0, you add 1 to your answer and it becomes 2, right? Then you check, does map contain cumulative sum? Yes, my map contains 0. My map contains 0. So it says how many times your 0 has come, add that to your answer. So 2 plus 1 will become 3. And then you put this value against this value, just add 1 to whatever was present. So this will become 2. And then this is the end of the loop. This is how your case will look for this test case. This is how your map is going to look by the end of all the iterations. What is the answer at this point in time? 3. This is what you are going to return after this iteration. So it will return you 3. So I hope now it is clear to you why and how we are solving this problem. So what we found is 0 itself was one answer that we found from here. Then 0 plus 2 is obviously not 0. 0 plus 2 minus 2 is 0. That is why we have added one answer. And because 2 minus 2 is also 0, so that is also has been included into your answer. If you have any doubts, you can ask me. Okay. So I think that's all for today. You guys can have a look here. And let me write that custom input which I discussed just now. So your value is 3 and we gave 0, 2 and minus 2. Let's compile. It should return you 3. Right? So that is all about this problem. I think we can wrap it up. See you all in the next lecture then, everyone. Bye bye. Take care. Thank you. Thank you, Monty. Bye bye.